times the integral of dx over c squared plus or minus x squared to the n minus 1. So in my problem here, what's n? So this is rather convenient, because if n is 3/2, that becomes 0. So this whole term here drops away. This 3/2, if n is 3/2 here, minus 1 gives me 1/2 times the 2 here. They cancel each other out. So what I'm left with, if n is equal to 3/2, is 1 over c squared times x over c squared plus or minus x squared. That's just 1/2, the square root. So what do you do on a quiz or test? You look at the top, because this is the formula that shows up. This integral shows up enough that I've given it to you at the top of all the quizzes and tests. And if it's not there, just ask.
So you'll give us that property?
Yeah, I give you, I can't remember which letters, if I use C or X or anything like that, but I give you this. I explicitly write 3/2 there.
Keep recording.
Yeah.
I think Jesse was actually just trying to see this.
Yeah.
Okay. So now, we can take our problem here. KQ1 lambda R J hat times. All right, so our C is R. Those are the same thing. So I have 1 over R squared times X over the square root of R squared plus X squared from negative infinity to infinity. Drop down here. So this R cancels out with one of those. And so up front, I've got KQ1 lambda over R J hat times, if we plug infinity into here, what do we get?
Zero. Or where? Plug it into where?
Plug infinity in for X here,
Oh. Wait.
not infinity. That's what I heard. Think incredibly huge number. If X is huge enough, this R becomes insignificant.
Right.
So we get the square root of X squared in the denominator, which is
Okay, so
X.
infinity over infinity is 1.
Yeah, we get a 1.
But you can't do that though.
Pardon?
The math people said you can't do infinity over infinity.
Huge number over huge number. Or if you want,
Take the 1.
for you math purists out there, 1 in every term. All right. The limit as X approaches infinity of X over the square root of R squared plus X squared. You're looking at it like you don't believe it. Or you, pardon?
One of the rules,
L'Hopital's rule.
L'Hopital's rule,
Yeah.
infinity over infinity.
Yeah, you can do L'Hopital's rule and then you'll probably get 1. I believe you.
There's actually another approach without using L'Hopital's rule. We have X over the square root of R squared plus X squared. Factor X out and of the denominator, and we're left with X square root of R over X squared plus 1. So as X becomes, so those would cancel out, and I'm left with 1 here. And then as X becomes huge, this becomes insignificant.
Nice.
There is a slight, technically, this should be absolute value of X. I'm gonna pull it out. So we plug in negative infinity, we end up with 1. If that's 1, then there is no force.
Didn't hear the negative.
We get a negative on top, the denominator is still positive, so minus -1. So we get a 2 there. And it looks like we're almost done. There are a couple things we have to do left to do. You know, pick the order you wrote the words. So 2k q1 lambda j hat over r. Now typically you're not going to see it in this form. There was a reference earlier to the permittivity of free space. There is another variable. I tend to use k here because it's just so much easier to write. But there is another variable that's related to k. K is equal to 1 over 4 pi times epsilon sub naught. This right here is known as, again, permittivity of free space. So if we plug that in for k, you get the more traditional form of this equation. And so we get it canceling out there, so I'm left with q1 lambda over 2 pi epsilon sub naught r j hat.
There it is. That's what I was looking for.
Yeah. Coulomb's law is assuming that you're dealing with basically a vacuum in between the charges. There's nothing in between it. This allows some flexibility, and we'll get into this in much more detail when we get to capacitors. But this gives us the flexibility of dealing with if there's another material there. Some sort of insulator in between. Now, there's nothing special about, in our original problem, we had the point below it in the j direction, but it really doesn't matter. If I could have the point out here, it's still the same formula. The direction might change, but it's going to be away from the line, no matter where I am. If it's an infinite line, it's somewhere pointing away from it, whichever direction it happens to be. All right, questions about force on a charge, some distance r from an infinite line of charge? All right. We're about to top that because we're going to do an infinite sheet of charge now. Yeah. And I'm going to take a bold attempt of starting on this end of the board and going just to the right, down or to the right, without having to cut back. See if it can be done. Infinite sheet of charge with uniform surface density, surface charge density. Sigma. Some textbooks will use eta. But if they go through the clever, a line starts with the letter L. Lambda starts with the letter L. Let's use lambda. Surface starts with S. Sigma starts with S. Let's go with sigma. And I have some point here, we'll call it Q1, a distance R away. That is a right angle there. So if we did a side view, if this is my infinite sheet here, there's some point Q1. I'm just going to call it Q. A distance R away. So side view. Jaunty tilt view. Any questions about what the problem's asking? All right, to do this, I'm basically gonna look at a ring of charge here that's centered at this point, the closest point to the charge. This is some distance r. So from the side view, basically this is some distance r. So every point on that red circle is the same distance away from Q. So it's like Q's pointing at the middle right there, and then there's a circle that surrounds it. What is the direction of the net force acting on little q here? Based upon what we know conceptually. All right, got one person pointing the right way. 2, can I get a third? There's 3. 4, woo. So it is going to indeed be that way. Symmetry argument, any vertical component will cancel out. So let's come up with some variables here. I'm going to call that theta. This distance right here, it doesn't really matter which direction it is. I'm just going to call it z. Why not? So I guess I just suddenly made that the z-axis. I have a ring of charge here. dq is that ring of charge. And so now we plug and chug. So this is the integral k q d big Q over r squared. Let's see, only horizontal components are safe. So cosine of theta. And let's call that the I hat direction. I hat. So k times the product of the charges divided by the distance squared, and then the cosine theta is, because we're only looking at the component that's horizontal component, because the vertical component's canceled. Pull the constants out, so I got kq I hat pulled out, and then I'm left with big dq r squared cosine theta inside my integral here. Looks very similar to what we just did, except I got a cosine here instead of the sine. That's going to cause the integral that we have to do ultimately to be different. I know that r squared is equal to z squared plus big R squared. I know that cosine of theta is equal to I feel that that's off there. Give me a second. We resolve in my head that I haven't made an error somewhere. Oh, okay. Yeah, there's another variable that needs to pop into it, and I've suddenly blanked on where it was going to show up. Now it's going to show up. dq. We're dealing with a surface charge density, sigma. What is that equal to? We did a linear charge density before, now we have a surface charge density.
Charge divided by area.
Pardon?
Is it the charge divided by area?
Yes. Or for a specific infinitesimally small bit, dq over dA. So dq is equal to sigma dA. A is dA is the area of this ring right here. So imagine I take this ring, I cut it open, and I stretch it out. I basically have a really skinny rectangle. The length of this rectangle is just the circumference of that ring, 2 pi z. Because z is the radius of the circle. Z. And the thickness of it is, well, the thickness of it is some infinitesimally small number in the z direction, since I picked z. So this direction is dz, or this becomes sigma times 2 pi z dz. We could have also just as easily done area is equal to pi z squared, and so dA is equal to 2 pi z dz. Get to the same place. Questions here before we start plugging in? So we got k, q, I hat times the integral of dq. We got sigma 2 pi z dz over r squared, which is z squared plus big R squared. That's a plus sign there. Times the cosine of theta, which is big R over little r, which is the square root of z squared plus big R squared. And then that simplifies in. We got a couple more constants we can pull out front. So we got the k, we got the q, we have sigma 2 pi big R I hat. And still left inside, trapped inside, we got z dz on top, and on the bottom, z squared plus r squared to the 3 halves. Take a moment just to let that soak in, the beauty of it. And dramatic pause for questions at this point. Is this in your way? Sorry about that. Austin, how many times have I told you not to put this up there? So now how do I do it? Oh, limits of integration. What's the smallest value of z?
Zero to z.
0?
To z.
Infinite sheet.
0 to infinity.
0 to infinity. How do I solve it?
Trig sum.
No, fortunately not. It's a little bit different. Before, we didn't have this extra z on top, so we had to do, looking up was easier, but we do have a z on top this time.
Is it u sub?
Yeah, u sub. So if we let u equal to z squared plus big R squared, du is equal to 2z dz. And hey, there's a 2z dz right there. So I'm left with k, q, sigma, pi, big R, I hat, integral of, I got du on top, and u to the 3 halves on the bottom. Now, the way that you are taught math now, do you not worry, don't change the limits of integration, figure out what the answer is, and then plug this back in, or do you change the limits of integration? Okay, so then therefore this would be, plug in that, so that becomes from R squared to infinity. Okay, Q, sigma, pi, big R, I hat, let's see, that's integral of u to the negative 3 halves du. So that becomes u to the negative 1/2 divided by negative 1/2 from r squared to infinity. AQ sigma pi r I hat. So we plug infinity in. Oh, negative 2 up front. From this. 0. Because that u to the negative 1/2 is the same as 1 over the square root of u. So if we let u become infinitely large, this is close enough to 0 to count for physicists. Minus, stick an r squared in there and we get 1 over r. So this becomes negative 1 over r. The negative signs cancel out. That goes away, which is nice. This r cancels out with that r. And what I'm left with is 2k q sigma pi I hat. Remember that k is equal to 1 over 4 pi epsilon sub naught. Get it in the more traditional form. So if we multiply both sides by 2 pi, we get 2 pi k is equal to 1 over 2 epsilon sub naught. Because I got a 2 pi k right there. So this becomes q times sigma over 2 epsilon sub naught I hat. A really interesting thing comes out of this, interesting to me. The fact that the distance does not matter. How far it is away from the sheet goes away. It's irrelevant. So, depends on the surface charge density and some constants, and then the force depends upon the charge. This also gives us a really nice shortcut if I've got 2 sheets, realistically not infinitely large. I'll forget if I don't do it now. These are definitely, I think we will agree, not infinitely big. However, if we put them close enough, so that distance between them is tiny compared to the size of it, it's just as close. This is a good approximation of infinite sheets when you think about something in between here. Now you might be saying, well, that's still kind of a large gap. Well, we can reduce the size of that gap just by sticking something skinny in between them. That is an insulator. Otherwise, if it's not an insulator, any charge built up on one is just going to go flow through to the other. But this is the essence of a capacitor right here. And this math right here will be doing a variation of this formula right here quite a bit when we get to that chapter. Chapter 27. Now, I'm figuring your minds are just blown away at just how awesome this stuff is. But if you can pull yourself back into reality just for a moment, are there any questions? Okay.
Can you calculate the bounds in which it becomes relevant for the size of the plate?
yes, then you start getting into some messy math. I can't do it just cold. I'd have to look it up again, just to make sure I'm not doing something stupid. But, probably the simplest way is you'd be doing, double integrals.
And it's related, it's mainly related to the distance up and down and left and right from the particle and its position on the plate, right?
Yeah, so there's a lab that we're gonna do where we actually have the plates pretty far apart. That will show that it actually stays pretty consistent between here up. There's a pretty decent size leeway that we have. All right, so this is basically, we've done most of chapter 23 here. And yeah, so why don't we go ahead and talk about the quiz. I know we're running low on time here, but because we only have class once a week, I still on the first quiz, let's just assume the quiz on chapter 23 will be 2 weeks from today. And the master set, yes, they are back. 3 weeks from today?
So the quiz is on the 26th?
Sure. But today is the 12th, so 14, yeah. So quiz on the 26th, and let's say master set, I don't want to pull it out, push it out too far.
This is chapter 26 quiz?
6 or 23?
23.
All right, so this is January, so 1,
Chapter 23.
26, the quiz on 23, and then you should have enough time. We'll make it do, so that's Tuesday, Thursday, the master set. So you'll have a lab and a master set due the same day. This will be master set for 23. So if you have not discovered it yet, the organization of the Blackboard site's a little bit different. I ultimately eventually would have to go to the new setup, so I just went ahead and did it. If you go in there, if you click on start here, that's where the orientation videos are, or for most of you, you can just jump straight to the assessment. And then if you go to coursework, you should see a thing that says chapter 23, you click on that, and you'll see videos, and then, or at least links to videos, a couple of quick and dirty problems for the most part. And then if you scroll down, you should see the textbook problems of which the quiz is based. I'm going to take 2 problems from the homework problems from the textbook, change the numbers, that will be the quiz, and then below that you should see the master set. And if there are other videos I've done of classes, you should see some links after that. You should see some links from previous classes with just absolutely spectacular footage and editing. If you've seen any of my videos, I think all of them are reordered. They're all going this way.
Nice.
So if you see one that's tilted the wrong way, let me know.
Do we
Not
have,
that that would ever happen.
do we have to print out anything for this, for the lab? Do we have a lab this Thursday?
Oh, you do have a lab on Thursday, yes. I don't know if I have it available yet, but at some point tomorrow, it'll become available.
Okay.
So for those who have not done the face-to-face lab with me before, or it's been a while, under labs, I do have labs separate from the chapter. So there should be a link that says labs. Click on that, and there should be a lab that is showing that will have a date close to the 14th. Don't always get the right date, but I get close. And it'll print out the lab before you come in. If you have printer problems, just let me know. Have a wonderful day, evening, night. Have a wonderful whatever you want. Be safe. Don't die. And don't kill anybody.
So this video will be posted later.
Yes. I have a video from yesterday. I still haven't posted yet, so just give me a couple days.
Yeah. Just the rain, the spring semesters haven't been this short before, have they?
The what?
The spring semesters haven't been this short before.
This short?
I noticed.
They, a couple of years ago, they went from 16 weeks to 15.
It's all right, though. There's no rush for it.
This was,
Yeah.
decision of the vice president of instruction. I don't know who was consulted, but it came across like, we just decided we were gonna do this. And now there's a push to go to 7.5 week classes, everything 7.5 weeks.
For faster graduation, or?
I don't see how it'd be faster, but
Yeah, it's probably retaking a lot.
there's some studies that show that students learn better, there's an optimum amount of time,
Right.
but I don't know if any of those studies have looked at physics.
Because I don't remember.
Duration
last
from math is
semester.
probably the key. Definitely latex.
Okay.
Yeah, I felt like last spring semester went into like May, so, and I noticed this one ends like April 30th, so I don't know.
Yeah, the last spring should have been 15 weeks also. Yeah, I think they were doing 15 at that point. They're just messing with your head.
Have a good one.
Yeah, you do.
So you want us to print out the lab?
Yes.
And bring it in?
Yes.
Okay. Thank you.
Yep.
Have a nice day.
Yep, you too, Trevor.